And then also they might come with questions which are like this, where they say find n. They give you maybe k equal to -1 all the way to n, and then they give you maybe 2k plus 4 is less than 200. They say find the smallest n such that this is less than 200. You do the same thing. You'd expand the left hand side just like how we did by substituting k equal to -1, k equal to 0, k equal to 1, k equal to 2. You'll just get the first three terms, which would be, you would have k equal to -1, and then you want k equal to 0, and then k equal to 1. Once you have these three, you then put that, and then you have the last one, which would be k equal to n. So here you would have your -1 plus 4, that is your t1, plus your t2 would be 2, your k is 0 now, plus 4, your t3 would be 2, your k is 1 plus 4, and there are some terms here. The last one would be 2n plus 4. And then once you do this, you know that this is less than, this case of is less than 200. So the left hand side is just going to be 2 plus 4 plus 6 all the way to 2n plus 4. This is less than 200. And then you know that the left hand side is going to end up being it's going to end up being simplified using the series formula. And if you check here, this is the plus. If you check here, this is going to be an arithmetic series. So meaning that we're using Sn is equal to n over 2 a plus n minus 1 times d. So we need a, but you know that a is 2. We need d is going to be t2 minus t1, which would be 6 minus 4, which is going to be 2. And then we need n. How do we find n? Remember, okay, so they used n here also, but we want n for the formula. Let's do this n for the formula. So I'm just going to call it n for the formula, because we also have an n here. But we know that, how do we find the number of terms to substitute in the formula? Always saying top minus bottom plus 1 from our sigma notation. So our top is -1, our bottom is, nope, our top is n, then minus, what is our bottom? It's -1, so minus 1 plus 1, so it's going to be n plus 1 plus 1, so it's going to end up being n plus 2. So in our formula, we don't substitute n, but we substitute n plus 2. That's why the importance of using top minus bottom plus 1 is important, because if you don't use that, you're going to be in trouble. So we now know this, so we can now go back and substitute here on our left hand side. So this was just our calculation, or reminding ourselves what do we need to get to use this formula. So we now know that the left hand side is just going to be the arithmetic series formula, which you're going to substitute n being n plus 2 over 2, and you've got the square bracket. So this is going to be, the form is going to be less than, the right hand side less than 200. So we have again our n is not n, or 2a, I mean 2, our a is 2. So let me just use these different colors. N plus 2 over 2, and then we've got a plus n minus, or a plus 1 times d. Our a is 2, so 2 plus 1 times d. Our d is 2 as well. No, this is n minus 1. This one is n minus 1 times d. So here we have n minus 1 times d. So we have n. Firstly, what is n? So we have n minus 1 times d. What is n? Our n for the formula is n plus 2. And then minus 1 times d, which is 2. And then this will be less than 200. Then we simplify this. Let's just leave this as n plus 2 over 2. Then it's going to be 4. N plus 2 minus 1 is going to be 1. So we're going to have n plus 1 here times 2. Then it's going to be n times 2 is going to be 2n plus 1 times 2 is going to be 2. So we're going to end up with a 6 plus 2n here. 6 plus 2n is less than 200. And then you want to get rid of the fraction, so you can multiply both sides by 2, multiply by 2, multiply by 2, because our thing is positive, so it's fine. Otherwise, if this was negative, we need to change the direction of our inequality sign, because if we multiply or divide by a negative number, we have to change the direction of our inequality sign. So in this case, we're going to cancel out. We'll be left with n plus 2 times 6 plus 2n is less than 400. Then you just expand this, and then you solve this, and you're going to get two values. In fact, let's just try to solve it. So it's going to be n plus 2 times that. I would rather put it like this and say 2n plus 6 is less than 400. So we have 2n squared, n times 6, we've got 6n, 2 times 2n, we've got a plus 4n, 2 times 6, we've got a 12. This is less than 400. So we simplify 2n squared plus 10n plus 12. Now this is, okay, let's just put it like this first. So now this is a quadratic inequality. So what we do, we really can't, we cannot say that, we cannot just factorize and say this is less than that. Like we cannot just factorize, maybe we say it's 2n plus 4, and then n plus 3 is less than 400, and then we say 2n plus 4 is less than 400. Or we can't do that because it's a quadratic equation and we don't have a 0 here. So only do that if you have a 0. Even if this was an equal sign, we can't say that 2n plus 4 is equal to 400 or n plus 4 is equal to 400, because we must always have a 0 here. The thing that happens if you're solving quadratic equation. So we need to bring this term into the left, because our quadratic is not in standard form. So minus 400 is less than 0, and then we'll have this is going to be minus 388 is less than 0. You can then solve this the way you solve, but you would first start by saying it is equal to 0 to get your critical values. Once you have them, maybe you get n is equal to 5 and n is equal to 17. Then you use your number line, or you sketch your graph, then you check where it is less than 0. But that's your algebra now. I'll just stop here for this question. Okay, you also need to know something that we call convergent series versus divergent series. So when does a series converge? This is only for a geometric series. So it converges if r is between -1 and 1. So it converges, which means that sum to infinity exists. Because it simply means that the more times you add to your sum, the sum does not increase that much. It increases slowly after some point. So then what is as infinity? We know it's a over 1 minus r. So you can only use this formula for sum to infinity if our series converges, which means if our r is between -1 and 1, only for a geometric series. So whenever they talk about convergent, your first step is to write this condition down, that r must be between -1 and 1. Then the opposite is true here, that if a series does not converge, it diverges. So if your r is greater than 1, so it's within this range, or your r is less than -1, then your series diverges, which means that sum to infinity does not exist. Why? It means that your terms are growing exponentially. Okay, and then we now have that. Then you also need to know the word problems. So basically, application of arithmetic and geometric sequences and series. So those are your word problems, which are your level 4 questions. And then also from a grade level, you need to know your quadratic sequence, which is that nth term. And then we know that if you are given a quadratic sequence, just say x, y, z, C, U, P, Q, R. Your first step is to do that, and then you get your first difference, which would be that minus that. So P minus Z, O, Q minus P, R minus Q. We call this your first difference. And what is important, what is interesting is that your first difference actually it is an arithmetic sequence on its own. Why? Because if you try to find the difference of the first difference, which is would be a second difference of the original quadratic, this will get a constant term here. Maybe we'll get z, and z is going to be a constant term. Then if we want to find this, we will equate this to 2a, and then we equate this first term here to 3a plus b, and then we say a plus b plus c must be equal to the 10. That's the quadratic sequence.